Today we're going to build a foundation for describing data so that numbers become meaningful instead of confusing. When you look at data, whether it comes from surveys, prices, scores, or measurements, you are usually trying to answer two basic questions. What is typical? And how much do the values vary? Everything we cover connects back to those ideas. Before choosing any calculation or graph, the most important step is identifying what kind of data you have. Not every statistical tool works for every type of data, and using the wrong one can lead to misleading conclusions. Some data are categorical. Categorical data place individuals into groups or categories. These are things like favorite food, preferred streaming service, major, iColor, political party, or yes and no responses. These values are labels. They are not numbers you can meaningfully add, average, or place in mathematical order. Because of that, certain measures of center do not apply to categorical data. You cannot calculate a mean for favorite foods, and there is no meaningful median for iColor. For categorical data, the most useful measure of center is the mode. The mode is the category that appears most often. It tells you what is most common in the data, which is often the clearest summary you can give. Other data are numerical. Numerical data represent counts or measurements. Examples include test scores, hours worked, commute distance, rent, gas prices, height, weight, or number of credits. With numerical data, you have several ways to describe what is typical, and the best choice depends on the situation. The first measure of center for numerical data is the mean. The mean is the average. You calculate it by adding all the values and dividing by how many values there are. The mean uses every value in the dataset, which makes it informative. However, that also makes it sensitive to extreme values. One unusually high or low number can pull the mean away from what most people experience. The second measure of center is the median. The median is the middle value when the data are placed in order from smallest to largest. If there are two middle values, the median is the average of those two. The key feature of the median is that it is resistant to extreme values, meaning unusually high or low values usually do not affect it very much. Because of this, the median is often a better description of what is typical when the data are skewed or include outliers. This is why medians are commonly used for things like income, rent, or home prices, where a few extreme values can distort the mean. The mode, which is the value that appears most often, can also be used with numerical data. It can be helpful when repetition matters, such as identifying the most common test score, or the most frequent number of hours reported. However, many numerical data sets have no repeated values, which means the mode may not always be informative. You may also encounter a measure called the midrange. The midrange is the value halfway between the smallest and largest values. You calculate it by adding the minimum and maximum and dividing by 2. The midrange is quick to compute, but it only uses 2 values. Because of that, it is very sensitive to extreme values and can be misleading if either the minimum or maximum is unusual. It can be useful as a rough estimate, but it should be used cautiously. When choosing a measure of center for numerical data, a helpful guideline is this. If the data are fairly balanced and do not include extreme values, the mean often works well. If the data include extreme values or are skewed, the median usually gives a more realistic picture of what is typical. The mode is useful when you care about what occurs most often, and the midrange gives a quick but limited summary. Now let's turn to the second major idea, spread. Spread describes how much the values vary. Two datasets can have the same typical value and still be very different because of how spread out the values are. The simplest measure of spread is the range. The range is the largest value minus the smallest value. It tells you the total span of the data. Range is easy to calculate and understand, but it has a limitation. Like the midrange, it only uses 2 values. One extreme value can make the data appear more spread out than most of the values actually are. That leads to the most important measure of spread, standard deviation. Standard deviation is often the concept people find most challenging at first, so it helps to focus on meaning rather than mechanics. Standard deviation tells you how far values typically are from the mean. That phrase captures the idea. Typical distance from the mean. If most values are close to the mean, the standard deviation is small. That means the data are consistent. If values are often far from the mean, the standard deviation is large. That means the data vary a lot. Think of the mean as a center point. Standard deviation describes how tightly or loosely the values cluster around that center. It does not describe whether values are high or low. It describes how much they differ from each other. Here's a concrete example. Imagine two groups that both have the same average number of hours worked per week. In one group, most people work about the same number of hours, close to the average. That group has a small standard deviation. In the other group, some people work very few hours and others work many more hours. Even though the averages are the same, the second group has a large standard deviation because the values are spread out. Standard deviation explains why those situations feel very different. Standard deviation is always zero or positive. It cannot be negative. A standard deviation of 0 would mean every value is exactly the same as the mean, with no variation at all. When using statistical software, you will also see variance. Variance is directly related to standard deviation. It is the standard deviation squared. While variance appears in output, standard deviation is usually easier to interpret because it stays in the same units as the original data. Another way data can be described is through relative standing. This is where percentiles and quartiles come in. A percentile tells you what percentage of values fall below a certain point. Quartiles divide the data into 4 equal parts. These measures help describe position within a dataset rather than a single typical value. For example, being at the 75th percentile means a value is higher than about 75% of the values in the dataset. That statement is about position, not averages. Boxplots use quartiles to provide a visual summary of the data. A boxplot shows the median, the spread of the middle half of the data, and the overall range in a single graph. Boxplots are especially useful for comparing groups because they allow you to see differences in typical value and variability at the same time. When working with data, a clear decision process helps. First, identify whether the data are categorical or numerical. For categorical data, mode is usually the appropriate measure of center. For numerical data, decide between mean and median based on whether extreme values are present. Then choose a measure of spread to describe variability. Range gives a quick sense of span, and standard deviation describes typical distance from the mean and overall consistency. The calculations and graphs can be produced by software. The real skill is choosing appropriate measures and explaining what they tell you about the data.